everybody. In this video, we are going to be looking at solving a logarithmic expression by graphing. So there are some times where we cannot do this algebraically, when we have to go to a graph to solve this. So an example of that would be the log of 2x plus 1 to the fifth power equals x minus 2. So something that I can do, and I'll just start out, is I will try to solve this. So I get 5 log of 2x plus 1 equals x minus 2. And then I'm thinking, okay, well, I'll divide by 5. So I'll get log of 2x plus 1 equals x minus 2 to the fifth. And then I think, okay, well, the only way that I can rid myself of this log is if I raise everything to the base of the log, which is 10. So now I have 2x plus 1 equals 10 to the power of x minus 2 over 5. And then we're going to keep going back in the circle because, again, the only way I could get rid of this base is if I turn it into a log. So I'd be going in circles trying to solve this. What I'm going to do instead is I will plug it into a graphing device. In my case, since this is a computer, I'm going to use Desmos. And I'm going to use my first graph as 5 log 2x plus 1, or you could just do log of 2x plus 1 to the fifth power. And y2 is going to be the x minus 2. All right, so going over to my graph, my first one is going to be 5 log of 2x plus 1. My second graph, and I'm just using that power property to move that 5 to the front, x minus 2. And there are my two graphs. So what we're going to look for is the solution for both graphs, which is basically where they cross, they intersect. So the first one here, they intersected 8.204 and 6.204, and the second intersection, I guess this one's the first because it's the leftmost, is going to be negative 0.329 and negative 2.329. All right, so we can see these points of intersection. Then the next thing we need to do is we have these solutions. Now we have to check the solutions to make sure that it is true to what it needs to be. So the solutions that we had here are negative 0.329. And, well, this is going to be x equals, I don't know why I put the parentheses there. Let me just erase that. Oop. And then the second one is going to be 8.204. So I'm going to try the negative 0.329. So x equals negative 0.329. So we have log of 2 times negative 0.329 plus 1 to the fifth power. Does this truly equal? I mean, it should. That's where they intersect. But we have to make sure that all the laws and properties are met. And we get this to be negative 2.329. Does this truly equal this? Yes, it does. Negative 2.329. So one of my true solutions is x equals negative 0.329, approximately. Then we could check the other one, x equals 8.204. And it should. We saw where they intersect on the graph, but let's just double check algebraically. 8.204, the point kind of vanished there, plus 1 to the fifth. This will equal 6.204. On the other side, I've run out of space here, but this does 8.204 minus 2. So we have 6.204 does equal 6.204. So my solutions here, and again, these are approximate because we did read them off the graph. And there are a couple more decimal places that go with this, but we're going out 3 decimal places. So we do have those 2 values for my solution. All right, a common error when doing this is when typing the equation into the calculator, it is helpful to write the equation using the power properties of logarithm rather than risking the incorrect input of the exponent. Because if you put log of the way they write it here, 2x plus 1 to the 5th power, it's probably going to read it as this value of log to the 5th power as opposed to what it truly is to the 5th power, something like that. So if you're using the power property, it ensures that you're putting this into the calculator correctly. All right, guys, so that is this example. If you have any questions or comments, please feel free to contact me, and I will see you in the next video.